Hi everyone, I am Christina Daly from the Department of ECE. In this lecture series, we are going to see about the topic Zener diode in the semiconductor devices and their applications. So these are all the contents we are going to see in this lecture series. The first one is the introduction, the Zener diode circuit, working principle, how it works in forward and reverse bias, Zener breakdown, VI characteristics, applications, and the last one is the conclusion. So before entering into the Zener diode, the first thing we have to know the symbol of the Zener diode, and it consists of two terminals, anode and cathode. From the symbol itself, the representation of Z specifies the Zener diode. So the Zener diode is basically an ordinary PN junction diode, but it works in the reversed bias condition. But ordinary PN junction diode, while that has been connected in the reversed biased condition, it is not used as the Zener diode practically. So why we are preferring this Zener diode and why it acts as a reverse bias circuit means it is a specially designed highly doped PN junction diode. So this is the circuit of the Zener diode. So we are applying the input voltage through the resistor, that is V1. So across the resistor we have connected the output voltage V2. So here it represented the Zener diode. So here we are going to calculate the value of the resistor to give the required value of the current, and the current can be measured in terms of voltage, that is in terms of the voltage and the resistance, that is V by R. So here we are having the voltages V1 and V2. Just we are going to apply the input voltage as V1, and across the Zener diode we are taking the output voltage. So V1 minus V2 divided by R. So this is the working principle of the Zener diode. Suppose if the normal PN junction is a reversed bias, what happens to the depletion region means the depletion layer will becomes wider. But here when we apply the reverse bias voltage continuously across to the diode, automatically what happens to the depletion region mean it becomes more and more wider. So at that time what happens, the constant reverse saturation current will be constant at the same time due to the minority carriers. So here the minority carriers get sufficient kinetic energy due to the strong electric field. So this is the forward and the reverse bias. We are having the P type as well as N type. In P type we are having the holes, and in the N type we are having the electrons. When the P type is connected to that of the negative and N type is connected to that of the positive. So here the electrons move from the holes moves from the electrons, and the electrons move from the holes. So here the depletion region will be wide. So here the free electron hits the atoms at the high speed. So at that time new electron hole pair is generated. So we are having both the positive ion as well as the negative ion. Suppose if the P type is connected to the positive and the N type is connected to the negative. So here it will be in the form of the narrow depletion region. So here the strong electric field pulls the valence electrons from the ions. So this is the Zener breakdown. So what is the basic principle behind the Zener diode working is, we are having two types of breakdown. One is Zener breakdown and the avalanche breakdown. This is the characteristics we have seen. So we are having both bias, that is forward bias and the reverse bias, and we are mentioning in the graph. So here I have represented the Zener breakdown and the avalanche breakdown. So since there will be no insufficient of current, when the current exceeds at that time the voltage gets breakdown. So that is termed to be as your Zener breakdown. So it will be always less than that of the Zener breakdown will always occur when it is less than 5.6 volt. Suppose in the avalanche breakdown, so if it goes high at the same time, if the voltage exceeds 5.6 volt, the avalanche breakdown occurs. So this is the VI characteristics. So here we have mentioned the forward bias and the reverse bias. So we have drawn the VI characteristics for both the forward bias region as well as the reverse bias region. Suppose if we increase the voltage, automatically at a particular point the current is increased, so that will be the forward bias. At that time we are taking the forward voltage as 0.3 to 0.7, so that is the cut-in voltage. Suppose if the current is constant and suddenly it gets decreased, so that point is termed to be as the knee point. At that time breakdown, it occurs the breakdown region. So here the voltage will be at the constant. So this is the characteristics of a Zener diode. So where we are using the applications, it is used as an voltage regulator, the switching operations and the reference voltage, waveform clipping and clamping, meter protection and load regulation. These are the applications. And finally we are coming to that of the conclusion. So it makes us an voltage regulation. At the same time it will be very simple, reliable and cost effective, and it will be used in the electronic circuits and the power supplies. So these are all the assessment questions regarding the Zener diode. Thank you.